So first of all, thank you very much for having me here today. I'm so excited to be at JSConf Europe. It's such a dream come true. So my name is Claudia Hernández. I'm from Mexico. And as you can see, I'm a huge fan of Alice in Wonderland. But you know, I'm also a front-end engineer in this French company in Paris called Dailymotion. So if you have any comments, suggestions, or even complaints, you can find me on Twitter as Coste4. Don't hesitate. But enough about me, because you know, you are not here for me. So for the following 30 minutes, I'm actually going to be your own personal white rabbit, because I'm going to drag you with me into the rabbit hole, and I'm going to show you some really weird things going on in JavaScript. But one thing's first, I'm not an expert. But I'm a really, really curious person, and I just really love to know how things work. This is one of the main reasons that I actually decided to do this talk. So most of the things that you're going to be seeing in the following slides are things that I have come across, and at the beginning, I didn't understand what's going on. So the beauty of JavaScript. JavaScript is this kind of language where nothing is what it is. Because mathmin is obviously not less than mathmax. Because in JavaScript, everything is what it isn't. Mathmax is equal to minus infinity, and mathmin is equal to infinity. And contrary-wise, what is not in JavaScript. Two totally similar-looking arrays are not the same, and what is not actually is. Did you get it? It's like, what's going on, JavaScript? What the fudge? So I'm not going to go into detail into the previous examples, but if you're curious about them, they all have to do with inconsistencies with floating point numbers in JavaScript and also in a lot of languages, and also knowing the difference between primitive and reference types. Now, the thing with JavaScript is that JavaScript is very easy to learn. Everyone can do a console log in their browser, but it's even harder to learn in a deeper and meaningful way. And this is our first part through Wonderland. And our first stop is nan. So nan literally stands for not a number. However, guess what? Yeah, type of nan is number. It's like, what's going on, JavaScript? So in really simplistic terms, nan is just the return value of a mathematical operation that failed. So if we try to do operations where both operands are not numbers, we will get nan. Or if we do things on numbers that are not defined, such as dividing 0 by 0, or trying to get the square root of a negative number, we will also get nan. So basically, nan is just trying to tell us something along the lines of, hey, I tried to perform this mathematical operation, but I failed. So here's this fail number instead. And maybe the label nan, it's a little bit misleading. Maybe it would be way easier to think of it as, I don't know, bad number, fail number, invalid number, more than not a number. Because bottom line, nan is still of numeric type, but it just represents a value that could not represent a valid number. So in JavaScript, mathematical operations can't lead to an error or crash. They just give us nan. So what if we actually wanted to know if a value is equal to nan or not? If this was your first guess, let me tell you something. Actually, nan is not equal to, greater than, or less than anything, including itself. But why is that, you may be wondering? So nan is not only a JavaScript thing. Nan is actually defined by this standard called the IEEE 754 floating point standard. And to keep things short, because this is a 30-minute talk, basically what this standard tells us is that there is 16,777,214 different floating point values as nans. What does this mean? This means that there are so many different representations of nan that it's highly unlikely that one nan is equal to another nan. So yes, indeed, nan is not equal to nan. I guess at this point, we can all agree that nan actually stands for not a number. So the only way we can actually know if a value is nan or not is using JavaScript built-in function isNan. So now let's talk about sorting arrays, because that's always fun. So can you spot what's seriously wrong in this code? Because I don't know about you, but normally in my world, 25 and 33 will be after number 4, not before. But you know, JavaScript, things are never what they seem. What's going on, actually? So what we're missing here is that JavaScript is doing lexicographical sorting. What is that? It's just like dictionary-like, alphabetical-like kind of sorting, not numerical at all. So what's actually happening under the hood is that JavaScript is just transforming all of the elements of the array into strings. And then for every character in those strings, it's comparing the Unicode code point value. So this code point value is just the Unicode ID of any character. So in this example, we have a color array, red and blue. We call the sort method, and blue is coming before red because alphabetical sorting. But in the second case, we have a numerical array with 80 and 9, and this will be the exact same thing as we call the sort method with those numbers as strings. So basically, 80 has a smaller Unicode code point value. So in a more simple way, we can just say that 80 is lexicographically less than 9. And it starts to make a little bit more of sense now. So if you want to know the code point value of any character, you can use the string code point add, the method. So going back to our previous example, now 25 and 33 are indeed lexicographically less than 4. It starts to make a little bit more of sense, but when we're trying to sort a numerical array, I guess lexicographical sorting is not the first thing we want. So what we're missing here is that the sort method can actually take as a parameter a compare function. So if a compare function is given A and B, if A is smaller than B, we'll return -1, and A will come before B. If A is greater than B, we'll return 1, and B will come before A. And in any other case, we will just return 0, and A and B will remain unchanged. Now, if you're as curious as I am, maybe, just maybe, you have wondered what's the actual sorting algorithm behind the native sort method in JavaScript. And the answer is that actually it depends on the JavaScript engine, because the ECMAScript standard doesn't really impose a certain algorithm to be used, so every JavaScript engine is free to use whatever they want. So now, out of curiosity, if you want to know, SpiderMonkey, for example, from Firefox, is using a combination of the merge sort algorithm and the insertion sort for smaller arrays for performance. And V8's Chrome is using quicksort and insertion sort. So that's just a fun fact for you people who love computer science. So going back to our previous example, now that we have finally provided a compare function, we can have a numerical sort. The tilde operator. How many of you have actually used this operator before? OK, a few of you. So this is actually a bitwise operator. And what's that? So a bitwise operator is an operator that will take a number, it will transform it into a sequence of bits, and then it will do some kind of operation on it, and it will return back a new integer as a result. And this is very important. Now, maybe, just maybe, you're familiar with the bitwise and the bitwise or, but huge warning, these are not the same as the logical and or the logical or. But there are actually 7 different kinds of bitwise operators in JavaScript. But today, I'm going to be talking about the Bitwise Not. So in really simplistic terms, what the Bitwise Not is doing is just inverting the bits in a sequence. So I know we normally don't do this kind of a specific bit-to-bit operations in our applications. So let me put it this way. The tilde operator is just doing this small algorithm. It's adding 1 and then changing the sign. So basically, we can just pass a -2, and we will get a 1. We can pass a -1, we will get a 0, et cetera, et cetera, et cetera. So the $1,000,000 question here is, what actual use in real life can we give to this operator? So one of it is by using a double tilde operator, double bitwise, we can actually truncate numbers. And this is faster than using math trunc or math floor. So we could actually use the other bitwise operators to do the same thing. And as I told you, this is faster. Now, another thing that we can use with the Bitwise Not is, imagine that if we want to know if someone is coming to the tea party that we're going to have later. So you know, the array function has this index of method. So the way this method works is that it will give us the position of an element if it was found on an array, and if it wasn't found, it will just return a -1. So a lot of developers have used this method to know if an element is in an array or not. And they will do a lot of these things. They will just compare if the result of the index of method is equal to -1, different than -1, greater than 0, or less than 0. But actually, all of this can be simplified by just using the tilde operator. Because basically what's happening here is that if the element was not found, the index of method will return back a -1. Then we will pass this -1 to the tilde operator, and it will transform it into a falsy 0. And in any other case, it will mean that the element was actually found. Now, before you start getting angry at me, I know that this is not very code-friendly and human-readable, so don't worry, because actually ES7 has this new function that is called includes, and basically it will just return us a Boolean that will say if the element was found or not. So don't worry about it, ES7 has our backs. Cool. So now let's talk about for loops. They can be fun. So I told you, I'm a curious person. Once I saw this for in a JavaScript book, and I was just like, I don't get what it means, what's going on. So now let me bring you back to those days when you were learning about JavaScript and variables and loops, and you were like so eager to learn everything. And let me remind you something really basic about JavaScript and for loops. So for loops have 3 parts. They have an initialization part, a condition part, and an iteration part. No biggie. But what I didn't know is that all of these parts are optional in JavaScript. So you can take the first part, because basically you can declare variables outside the loop, and it doesn't matter. Or you can remove the condition part, and if you do that, JavaScript will automatically consider it as true, and then it's up to you to break the loop. Or you can even take the iteration part apart. Away. And in this case, the condition part is acting at the same time as the iteration part. And once this I drops until 0, it will be a false 0, and then it will get away of the loop. So basically, also, you can just remove everything. And if you do that, as I told you before, the condition part is going to be automatically considered as true. And basically, this we're looking for is just an infinite loop. So cool. Last but not least, let's talk about undefined. So we all know that undefined is this variable that has been declared, but at the moment holds no value on it. So this shouldn't be weird for anybody. So undefined is actually part of the global object, the window object. So what would happen if we wanted to be really clever and define undefined? So actually, the result of this piece of code actually depends on the browser that you're running it. So for older browsers from Internet Explorer 8 and below, you could actually redefine undefined. The good news is that this has already been solved for modern browsers. And now I get it. While it's becoming less and less of a problem, we have to take, we have to care about these kind of issues, because if you support older browsers, there is a possibility that people might try to define your undefined. So the thing with JavaScript is that JavaScript rarely runs in isolation. We often run it with other libraries, with external code, so just be careful. But the madness doesn't stop there. Actually, undefined is not a reserved word in JavaScript, meaning that you could use it as a variable name, which I totally don't recommend, of course. So what have we learned so far? Not a number is a number. Array.sort sorts lexicographically by default. The tilde operator is the Bitwise Not operator. All parts in a for loop are optional, and undefined can be defined sometimes. So am I boring you? Is this like, not that fun? No? Wait, because the mad JavaScript party is just about to begin. And before I start talking about it, just a little bit of a disclaimer. The following content is designed to challenge and amuse programmers, not made to be suitable for practical use. And now I'm going to talk about non-alphanumerical JavaScript, which is JavaScript without letters and without numbers. But before I get into it, I'm going to keep repeating something that we have been hearing in the previous talks. JavaScript is a dynamically typed language, which means that we don't have to declare the type of data that a variable will hold when we are declaring it. So this is the job of the interpreter. Now, when we mix types, we can have really, really weird conversions that can lead to really, really crazy results. And what I'm going to show you next is how to write valid JavaScript only using square brackets, parentheses, the curly brackets, the plus operator, and the exclamation point. I swear I'm not crazy. This actually works, and you can follow along on your developer tools. But before that, I'm going to explain something really, really basic on JavaScript. I've been talking in the previous slides about falsy and truthy values. So here's the thing. Everything in JavaScript has a Boolean value. Everything can either be falsy or truthy. And how can we know that? So the golden rule is this one. Everything in JavaScript is truthy unless it's falsy. And You know, it's true, because the falsy values by default are false, 0, an empty string, null, undefined, and none. And the truthy values is everything else. And it could either be a string 0, a string false, an empty array, or an empty object. Now, the basics. So in this example, in the first one, what we're trying to do is we're trying to negate an empty array. So we're forcing JavaScript to treat that empty array as a Boolean type. And if you remember from the previous slide, that empty array is just a truthy value. So we're negating a true, so we get a false. And the second example, we're negating false, so we get true. Now, from false and true, we can get to 0 and 1 by just using the unary plus operator, which actual function is to just transform things into numbers. Now, guess what? Once we have 0 and 1, we have a base to create any other number. You can just picture that as adding 1 plus 1 plus 1 plus 1 until infinity. So we can also convert things into strings. So in JavaScript, you can only concatenate things with the plus operator or add numbers. So if you try to put anything else over there, JavaScript is going to automatically try to transform it into either a primitive type, a number, or a string. So in this first case, the first part is just a false, which is a Boolean type, which is a primitive type. And the empty array is automatically transformed by JavaScript into a string. So these actually give us a string false or string true. And this works the exact same way for numbers. We can convert numbers into strings using this technique. So what if we wanted to do bigger numbers? Because we're not just going to add 1 plus 1 until infinity. Here's the thing. We can actually just transform into strings every single digit, and then concatenate those digits back and transform the whole thing back into a number. So 123 actually looks like this in non-alphanumeric JavaScript. So we can also get words like undefined by trying to access an element that is not found on an array. If we try to transform an object into a number, we will get none. And if we try to transform an object into a string, we will get the string object. So now that we have access to all of these words and vocabulary, what we can actually do is transform it to strings, as I showed you before, and access every single character as if they were arrays. So if you're following along, perhaps you might notice that what we can do is we can try to make up functions and works that actually mean something to JavaScript. So actually, Martin Kleppe, that he should be somewhere around the crowd, he's the creator of a website called JSConf. He will call this technique like JavaScript Scrabble, which I love the term because I think it's really clever. Because basically what we're trying to do is, given the set of characters of words, we're trying to make up functions that actually mean something to JavaScript. So to keep things short, basically we can have access to call, concat, constructor, join, slice, sort, and filter. Now, how does this actually look in action? And I'm going to show you step by step so you will understand. So this piece of code is only just doing an alert one in your browser. And here's how it works. So the first part is just an empty array. No surprise there. Now, the filter segment is just trying to access the filter function of that empty array, which is a function. Now, the constructor part is just getting the constructor for functions. And the constructor of functions can actually take as a parameter a string that will return back a new function with that string as its body. So now you can finally guess that the last part is just auto-executing that new function. So basically, this will give us in our browser an alert one. And the code behind it is the code used to actually make this work, and it does work. So yeah, JavaScript is confusing sometimes. But if you're really interested in the technique, you can find a lot of converters online, and I really encourage you to actually check the open source, the code source, sorry. And there is Hieroglyphy demo, there is JSFuck demo, there is SitStart.js, JSScrewed, and the most well-known is JSFuck from Martin Kleppe. So there is no limits with this. Actually, when I was doing research for this talk, I came across this repository, which is called jQuery Screwed, in which basically the guy, he just like rewrote the whole jQuery library using this non-alphanumerical technique. I think this is the source code. So a lot of people have like way too much time on their hands, not like me. So And at this point, you might be wondering, like, Claudia, I would never write JavaScript that way. Why should I even care about these things? And one good reason could be security. And this is a tweet by Martin Kleppe from a few months ago, in which he was pointing out to a blog post from a security researcher that he found a vulnerability on eBay. And basically what he realized is that he was able to inject malicious JavaScript into eBay by using this non-alphanumerical technique. Because basically what eBay was doing is filtering tags such as script or iframe, but it wasn't aware of this technique. I guess by this time it's already fixed. So yeah. And we're reaching the end of our journey. This is our last part. But I can't leave without talking about arrow functions, because they are so much fun. Now, this is a piece of code that I guess most of you have seen in your applications. Like, this is very common to see. And it doesn't work because the context of the function that is inside the setTimeout function is no longer in the same full context. So a lot of developers have actually solved this issue with the other, but by adding new variables such as self equal this or that equal this. But actually, there is one thing. Arrow functions don't have a this at all. Actually, they don't have a this, they don't have arguments, they don't have super, and they don't have new target. Any reference to them will just lexically resolve up. So now we can actually rewrite the previous example by just using an arrow function. And in this way, we can reference to the full context, and we will actually have something being displayed. So what if we wanted to be really, really stubborn, and we actually wanted to hard bind something on the arrow function? It's not possible, because since arrow functions don't have a context at all, there is nothing the bind method can actually grab on. So I guess what I want to say with this last part is that arrow functions are not about syntax sugar, it's not about writing less. They actually have a behavior that we have to learn how to use and use it accordingly. So was it all a dream? Sadly, no, this is real JavaScript. This is the thing that we have to deal every day. So, but why should we care? Why should we care about all of the nonsense that I just showed you? First of all, knowledge is power. We have to know where we're writing the code we're writing and how it works. We have to push the limits. It's us who has made JavaScript this amazing language that is running on our servers, on the desktop, everywhere. We have to push it to the limit. We have to break rules. And don't forget that playing is learning. For me personally, it's this quirkiness of JavaScript that just makes me want to continue working on it, make mistakes, and just play around with it. And this is ultimately what makes me every day a better developer, just diving into the language itself. And it's the power of the language. And this is a quote that I really like that says, JavaScript is a language that has survived, not despite its flaws, but because of them. And last thing, I just want to read this quote from a really, really good book that I recommend from Angus Kroll, that it's called If Hemingway Wrote JavaScript. And it says, the best JavaScript developers are those who obsess about language, who explore and play with it every day, and in doing so, develop their own idioms and their own voice. And that's all for me. I hope you liked it, and danke schön.
Thank you so much, Claudia.